Now we're going to solve the initial value problem using the method of Laplace transform. Sketch the graph. We don't have to worry about that. Unless you have some kind of software, don't worry about the graphs. So we're going to solve this equation. We will apply the Laplace transform on this. And this would be s squared w minus s times s of 0, which is 1, or w of 0, which is 1, but that's 0, so that's it, plus when I get to capital W, here I get again e to the negative 2s, and there's a 1 in front of this, so the Laplace of that is 1 over s, minus, to take care of this shift, that's e to the negative 2s, there's a 1 in front of it, 1 over s as well. So just to set this up, this starts at 2 and terminates at 4. If you were to do this, at 2 it starts. You don't need that graph, I'm just explaining how this works. It runs all the way. Once you hit 4, since that's a -1, it zeroes out again. So this thing runs only for 2 seconds. Well, to us, it doesn't really matter. Let's get the w's. So w into s squared plus 1 equals, let me shift that down a bit, or shrink those a bit. I made that too big. Here we go. Better. So that's going to be e to the negative 2s divided by s minus e to the negative 2s. I'm sorry, that's not 2s. That's 4s. That's a 4. And if I move this to the other side, plus s. So altogether, I'm looking at w equaling e to the negative 2s over s times s squared plus 1 minus e to the negative 4s divided by s times s squared plus 1 plus s divided by s squared plus 1. Now if I take 1 over s into s squared plus 1 and break that up, that turns out to be 1 over s minus s over s squared plus 1. So in turn, w equal e to the negative 2s times 1 over s minus s over s squared plus 1 minus, you know what, let me put that on the bottom, am I going to be able to fit it all? There we go. Minus, e to the negative 4s times 1 over s minus s over s squared plus 1 plus s over s squared plus 1. Now we know if you apply the inverse Laplace transform on this, this is going to give a 1, this is going to give a sine, a cosine of 1t. So in the first case, when we apply the inverse Laplace transform to figure out the solution, w of t, not of s, will equal. So we know that this is going to be the case for this, but we're going to shift it by -2. 1 shifted left or right is just 1, that doesn't matter. Minus, this should be the cosine we said, but we're going to shift it. It's going to be the cosine of t minus 2. Those two multiplied by u of t minus 2. The same deal here. This should be exactly this, but we're going to shift that by, so that's a 1. This cosine will be the cosine of t shifted 4 units to the left, and those are multiplied by u of t minus 4. And this is nothing more than so stuck on the sign. The cosine of t. And that would be the solution. Of course, these are using 11, and this is using, I believe, this is 1, and cosine is using, what's that, 6. And the rest is the same. Alright, so that's really how we're going to use this to solve differential equations. The table is representing the integration, and these are actual applications. If I apply the Laplace on this problem, u of 0, well, let's see how that works. That would be, by the way, I do want to mention the sine of t and the sine of t minus 2 pi is the same. Shifting it one full unit makes no difference. So if I make that the sine of twice t minus 2 pi, it's the same as sine of 2t. So when I apply the Laplace, I get s squared pi minus s times 1 minus a negative 2 plus 2 plus on y, that's simply capital Y. Now here, this by itself this is 3 times 2 over s squared plus 2 squared, which is 4, minus 3 times e to the negative 2 pi s and instead of that will be 2 over s squared plus 4, and now if I take a y out of this, I'll have s squared plus 1 equaling, I could take the 3 out of the whole thing, or I could just leave it. That is 6 over s squared plus 4 minus e to the negative 2 pi s, 6 over s squared plus 4, and if I move that 2 to the right and the s to the right, plus s minus 2. So here, I will say y equal 6 over s squared plus 4 times s squared plus 1 minus e to the negative 2 pi s, 6 over s squared plus 4 times s squared plus 1 plus s over s squared plus 4 minus 2 over s squared plus 4. Now, I will go on the side and figure out that 6 over s squared plus 4 into s squared plus 1, that turns out to be 2 over s squared plus 1 minus 2 over s squared plus 4. So if I plug that in, I'm really looking at a y equal 2 over s squared plus 1 minus 2 over s squared plus 4 minus e to the negative 2s times 2 over s squared plus 1 minus 2 over s squared plus 4 plus s over s squared plus 4 minus 2 over s squared plus 4. And if I apply the inverse Laplace transform, I'll find the solution where it's f of t or y of t. This will be simply twice the sine of t minus minus the sine of 2t I'm not mistaken. This will be the cosine of 2t minus the sine of 2t and this should be the same as those, except that's going to be twice the sine of t minus 2 pi, that's the same as t by the way, minus the sine of 2 times t minus 2 pi. And that will be the solution. And there it is. Now 26. If I apply the Laplace on this direction, solve the initial value problem. Well, both of those are 0, so that's quick. That's going to be s squared y plus 4y. No s's because they're going to 0 out. Plus 4. No. Plus sy plus 4y equal, and this is going to be e to the negative pi over s minus e to the negative 2 pi over s. Again, this system starts at pi and terminates at 2 pi. So, if I really think about this, I could take a y out, s squared plus 4s plus 4, that is s plus 2 squared. So if I divide, I'll get y equal e to the negative pi over s times s plus 2 squared minus e to the negative 2 pi divided by s into s plus 2 squared. Now on the side, I would figure out that 1 over s into s plus 2 squared really equals 1 over 4s minus 1 over 4 over s plus 2 minus 1 over 2 over s plus 2 squared. So here, when I apply the inverse Laplace transform, I'll get y of t equal, well, we know what this is going to be. This is going to be simply 1. This is going to be e to the negative 2t, and this is going to be t e to the negative 2t. Here, I'm going to shift all of these by pi, so that's going to be 1 minus 1/4 minus 1/4 e to the negative 2 into t minus pi minus 1/2 into t minus, so I shift all the functions, t minus pi e to the negative 2 into t minus pi. When I get to this piece, times u of t minus pi minus 1 over 4 minus 1 over 4 e to the negative 2 into t minus 2 pi in this case, minus 1/2 t minus 2 pi e to the negative 2 into t minus 2 pi, and this is going to be multiplied by u of t minus 2 pi. And there's the solution for that one. Last problem. I wanted to do an application, but then it took a lot longer than I thought, so I'll probably send that as an announcement maybe later on. Take the Laplace. That's going to be s squared y minus, that's a 0, minus 1, plus 5 times s of y minus 0 plus 6y equaling. Now here I need to make this t minus 2 plus 2. So that's going to be t minus 2 u of t minus 2 plus 2u of t minus 2. So when I apply the Laplace on this, that's going to be e to the negative 2s. And that shifts that, make it a t. T is 1 over s squared. And this is going to be just plus twice e to the negative 2s divided by s. And now if I work the left hand side, I'm looking at s squared, y into s squared plus 5s plus 6 So y is going to equal e to the negative 2s over s squared into s plus 3s plus 2 plus twice e to the negative 2s divided by s into s plus 3 into s plus 2. And if I take 1 over s squared into s plus 3 into s plus 2, that turns out to be, if I'm not mistaken, 1 over 6 over s squared plus 7 over 36 over s minus 3 over 4 over s plus 2 plus 5 over 9 over s plus 3. So keep in mind, when I apply the inverse Laplace transform, y of t is going to equal, and we know how this works. When you apply the inverse Laplace transform on this, you get a 1, this you get a t, this gives e to the negative 2t, and this gives e to the negative 3t. Well, let's see. In this case, we're going to shift all of them by a negative 2. So the first batch will be 1 over 6 t minus 2 plus 7 over 36 times 1, that's 1, minus 3 over 4 e to the negative 2 into t minus 2 plus 5 over 9 e to negative 3 into t minus 2, and all of these are multiplied by u of t minus 2 plus the same deal, but you multiply it by 2. That is 1 over 6. It's t minus 2. Those were the same. Let me check. Oh, I forgot about the 1. So there's a plus 1. And when you divide by that, I have 1 over s plus 3 into s plus 2. and that turns out to be 1 over s plus 2 minus 1 over s plus 3. Yeah, I forgot about that one. That was... okay. Plus 7 over 6, 36 times 1, minus 3 over 4, e to negative 2 into t minus 2. All those are the same. I should have combined them. Plus 5 over 9, e to the negative 3 into t minus 2, and that's multiplied by u of t minus 2, plus, yeah, when I move the 1 over, it becomes a plus 1, and there it is, e to the negative 2t plus e to the negative 3t. Now the green and the... oh, I could have combined those. I could have combined them into... well, you could do that. So what I'm trying to say is, I should have made those into 1. That could have saved me a lot of work. And that's pretty much it for this section.